Jai Ram Krishna. In this session, I will explain Archimedes' principle. What is the basic principle behind ships, submarines, hot air balloons, hydrometers? It is Archimedes' principle. When a solid body is partially or completely immersed in a liquid, it experiences an upward force that is equal to weight of the liquid displaced by the immersed volume of the object. To understand this, here I am taking a container in which I took a liquid of density rho L. Now I dropped a solid body of density rho S. It is in static equilibrium. It means that downward force weight is equal to upward force. Here what is providing upward force? Let us understand this diagram. Here on this object pressure will be acting on from all directions. Here I am taking 2 points A and B. Point A is on the top of the object, point B is at the bottom of the body. Here as we go down, pressure increases. So pressure at the bottom will be more and pressure at the top of the object will be less. As force is nothing but pressure times area, as area is the same, pressure at the bottom is providing more force than pressure at the top. Here magnitude of lengths indicate the magnitude of force. So upward force is greater than downward force. This upward force is giving or balancing weight of the object. Here horizontal forces will cancel, only vertical forces will be unbalanced, and that unbalanced vertical forces are balancing the weight of the object. Here what is providing that upward force? Let us try to understand by taking another example. I am taking the same liquid of density rho L, but this time it is completely filled in the container. Now I dropped the same object. Because there is no space, that liquid will spill out, and that spilled liquid I collected in another container. This is the liquid I collected. Volume of this liquid displaced and volume of this solid body will be same. If I measure the weight of this liquid displaced, this weight of the liquid displaced will be acting as an upward force called buoyant force or upthrust. Here weight of the solid body is equal to buoyant force or upthrust. What if total volume of the body is not immersed? Let us take one more example. Here I am taking the container in which I filled a liquid of density rho L. Now I dropped a solid body. Let its total volume is V and immersed volume is Vi. As I drop a little bit, volume will increase. That volume will increase means it will move up, the liquid will move up. Now weight of the solid is balanced by the weight of the liquid displaced by the immersed volume. What is weight of the solid? That is mass of the solid into acceleration due to gravity. What is weight of the liquid displaced? That is mass of the liquid displaced into acceleration due to gravity. These two gets cancelled. What is mass of the solid? Mass of the solid is nothing but density of the solid into total volume of the solid. What is mass of the liquid displaced? That is the density of the liquid into volume of the liquid displaced. What is volume of the liquid displaced? That is immersed volume of the solid. From this I can write rho S by rho L is equal to Vi by V. Here Vi by V gives the volume of the solid immersed, fraction of the volume of the solid immersed. Using this we have three possibilities. First possibility is what if rho S is less than rho L? What if rho S is equal to rho L? And third one is if rho S is greater than rho L. If density of the solid body is less than density of the liquid, the body will float, and fraction of the body immersed, fraction of the volume of the body immersed is given by this equation. Vi by V. In this case, the body will float. If density of the solid body is equal to density of the liquid, in this case, the total body will be immersed in the liquid. If density of the solid body is greater than density of the liquid, then the body will sink. These three are called laws of flotation.